Thank you, Mr. Schneider. I invite you here to stay on the stage. It is always important to invite also to discussion people who have tested these technologies. So that's why from Norway, we are inviting Cato Christiansen, Chief Technology Officer, Capsol Technologies. And to explain also this maybe more from academic approach, I'm inviting Professor Katarina Malaga, the Vice President of Business Development and Sustainable Construction, RISE Research Institute of Sweden. Mr. Schneider, you had your part of talking, so we already know what's happening here. So I think we will start with our guests. So if you should explain how this thing works in reality, Cato, please.
First of all, thanks a lot for being invited. It's really an honor and a beautiful day and a very nice cement plant. So looking at how does the capture technology work, it is fairly a new technology. I would say it is new in terms of doing it to reduce the greenhouse gas emissions. But this technology builds on, you can go back 100 years really for the start of these solvent technologies, that hot potassium carbonate that we use, but there are also others. And this was developed originally for various industrial gases where you either need to take out some of the CO2 or you needed to produce some CO2 for beverages or for industrial use or dry ice or all of these things. I would say when we come to the early 2000s is when we see a lot of focus and what we talk about here, which is post-combustion technologies with, in our case, a liquid solvent. It's the same principles that was used in the beginning, is that you have some sort of gas with too much CO2, right? And then you have this liquid, typically based with mostly water, but with some chemical that will extract the CO2. It will bind the CO2 for itself, right? So you bubble all your flue gas coming out before you stop it before the chimney, put it into your these large towers that was shown, and you bubble the gas through, and you have the liquid dropping down, and inside there you have a material that really increases all your surface area, so you get as much contact with the flue gas as possible. You take up the CO2. And then when that is done, it's a continuous processing. This fluid that now is filled with CO2, it will go into a regeneration section that will need some kind of energy, typically heat. And then you heat up the liquid again, and the CO2, pure CO2, will boil off. So then you have separated two streams. You have the flue gas where you removed most of your CO2. Typically the projects we see, they are around 95% of what was originally in the gas. And then you're left on the other side with a pretty clean stream of CO2. That's the main principle.
Okay. If we combine all the plants together, we heard 2,500 tons per day. So it is quite a lot. So if we combine all that together, is there a use for all that gas?
The question is actually always we can capture, and what do we do with this? So the amounts. Of course, there will be a huge amount of access to the CO2. And I would say the food industry will not absorb everything. So we are looking all the time for this CCU. And the U is utilization. What do we do with this? Of course, we are looking for industries which are focusing on large volumes. Building industry, construction industry. So what we are looking for is if we can actually utilize this to produce different types of building materials right now. So we do so-called carbonation. Many research organizations actually in Europe, including us in Sweden, we are looking what to do with this and how efficient it is. Utilization is one part because you can use it and store it in the building, like houses or bridges. you could store it for at least 100 years. We, of course, want to extend this service life as much as possible, but we are also looking at other uses, but I would say the volumes will be in construction business.
Yeah. Can you explain maybe also the onshore and offshore, how it works, maybe if is there a difference in some elements?
If you are talking about the position of CO2 under the sea level, I think, I don't know if you can explain it, but this is one which is right now available. It's in hands of Norwegians.
Yeah.
So maybe you can explain it better than I.
I can talk a little bit. I've in my previous life at least worked a little bit on storage, but if you're talking about the fundamental principle of it, either if it's stored onshore or if it's offshore, it's not really a difference. Typically, it is the same type of geological formations. It's typically a sandstone. It could either be a sandstone that previously had oil and gas and has been emptied, or it could be a sandstone that contains a saline, so salt water. And that is what for this Northern Light project that many have heard of, that it is a saline aquifer, so there's no oil and gas there. And then it's 3,000 meter under the sea bed or sea bottom. And you would have similar on the onshore, would be just similar. Onshore has some major benefits. It's very costly to drill all these wells and do all these things offshore. It's much cheaper to do it onshore. But onshore has more of the, you might be closer to where someone lives, and you have these kind of, call it public relation that you definitely need to work well on.
I fully agree, and that's of course what we are looking into at what options we have, but we're looking into all the options. But also with commenting what Katarina was saying, I think it is important to look at these usage cases, and I think it can be used. We even want to try now to use the CO2 which we produce here, 2 tons per day, we want to use in our recycling water in the concrete production. There are some applications, but of course the volumes are much too big. Nobody can use 2,500 tons per day. So we still believe that maybe we can use 10-15% in certain applications, but the main thing has to go to the storage places and be stored. But there are applications. I think it's good building materials, synthetic fuel production and things like that.
I can just comment on one geological aspect. I'm actually a geologist at the base. So it's when you pump down the CO2 in those old oil and gas depositories, actually you have like a cap rock, which is keeping this also at the spot. Because this is also a question for many people. Is it going to be evaporating or just gassing off? So it's in most cases not. Some leakage can be, and this is also important to say that the CO2 is not a dangerous gas. It's not toxic, so it's there is no danger in storing the CO2 actually under the sea level. But what is happening geologically in time is the CO2, carbon dioxide, is actually reacting with rock. The sand, in the sand is mostly calcium which is present, and then we expect that with time it will be actually limestone again.
Yes. Mr. Schneider, can you explain how this process will look like if you are going to implement it? You need to probably work with different kind of stakeholders, and so how this process will look like?
Yeah, I mean, that's one of the main topics at the moment. We are working in different directions. Of course, we look into the topic of onshore storage, but we also look together with partners who are here as well, that we still have as a backup option offshore storage, that we go through terminals. At the end, it starts all here in the plant. So, of course, we need to, in most of the cases, we need to liquefy CO2 because we need to bring it somewhere. either with pipelines, if it's close, or if it's also further away, or we can also use railway. That's one of the preferred options, what we are looking at the moment, that we discuss to really have a railway connection if we are not fast enough with the pipeline. But these discussions we have at the moment, also Connexus is here today, other pipeline, also in other countries this is discussed, how to create a pipeline network. So this is the main discussion we are leading, and we need really partner and support of the government, because that's really as well infrastructure, which has to be to some extent provided by the government, but we, of course we are also ready to be part of that in financially, but as well in the development.
Yes, and policy-wise, of course, we are leading, one of the leading in the European Union. In that context, then how about some policies? What we need to implement in that way?
Yeah, I think we need to. There has to be additional policies. What I said is in my speech, it is a new topic. So, as I said, there is no policy at the moment to transport CO2 in trains. So this has to be regulated, and also the onshore storage. I mean, we have now this new law of subterranean depths here in Latvia, but there needs to be additional regulations based on that. But I think the second panel will also deal to some extent with that. I hope we have as well Jānis Irbe here. Yeah, he is here, so he will also. I think he knows already part of this what had to be done.
Yes. If we talk about the value chain and what else actually is there possibility-wise, I mean, Kato, if you can elaborate on this one.
Yeah, on that's first of all one thing that we discussed a little bit earlier. I think this I have had so many times. This is a question of storage or use. I think that's not a thing. I think the best value chain you will build if it's both storage and use, and both of them, will actually complement each other. So that's, but it's a complex project for a plant like here. You're situated somewhere for the storage. You need to do the capture. You need to get transport, and there are many ways. Should you be in charge of it yourself? Is it a third party doing the transport and storage? Are these two separated? Is it one transporter, one storage? There are many kind of options and all sorts of regulations, and it comes in. I guess for here, we see several of our projects which is coming up now, this biogenic part. Maybe not so large for a cement plant, but it could be in case you use biogenic fuel, and then you can get some of that CO2 certified as biogenic, and be able to sell these removal credits as part of the whole value chain to keep the wheels running. It could be an option.
I was just thinking, if we do not have options to store it locally, we need to do transportation. So in that sense, there's extra CO2 emission.
No, maybe I can answer. We were calculating that in this innovation fund application. There is a certain extra CO2, but that's already included. So you can offset this extra CO2 with the biogenic CO2 you're catching as well from our alternative fuels. So we still believe that setting off these transport CO2, which is of course much less if you have onshore storage, which is maybe only 50, 100 kilometers away, then it's less, but you can set this off. But maybe we would be good also to hear from Katarina a bit this topic of, we talk about CO2, but I think it's also interesting to talk about the products we get, our cement products, because that's also the other side of the coin. We know, okay, CO2 is a product, but the even more important product for us is still cement. And we see there is a big need for CO2 reduced or CO2 neutral cement. And I think that is one of the main drivers as well for us, that we have to do that. We will otherwise lose these markets. And I think Katarina from Sweden, you can say a bit where this is coming from, and where is this at the moment in Sweden, the situation?
Sweden want to be the best country in the world in concerning the CO2 capture emissions, and it's not only about the cement industry. Actually, we are looking also at other types of industry or emitters. So 2019 in Sweden, industry and not only construction industry actually agreed that we produce so-called roadmaps for climate neutrality. The government was heavily involved in this, was supporting the action, and is supporting until now. So we produced around 25 of roadmaps for different industries, where we committed that 2045 Sweden will be climate neutral. This means that we need to take action. So since 5 years, I've been leading the project for implementation of the 2 roadmaps. And one was for cement, and the other one was for concrete. And then we are coming actually to the product, like you are saying. The cement, as you said before, cement is one of the most important products actually we have. So we are producing over the world more than 4 billion tons. So it's, and this number maybe is not saying you so much, but if you are using this concrete which we make actually with cement, then you understand that we can build a New York City every month, the new one. So it's so much material we are using, so that we are talking about cement, we need cement. And another thing which I want to also say, that everybody is talking about the CO2 emissions from cement, but if you put cement and how much CO2 is actually emitted per kilo or ton, then you have exactly the same amount as bananas. So it's, I'm trying to always explain to the people, it's not the emission from the cement per volume or weight, is the amount, because we are massively using cement over the world. And this is actually the main issue, where we are coming to the point that we need to lower the emissions because we need this material. So in Sweden, we committed that we will actually lower the emissions. Of course, Heidelberg Materials, we have only one producer in Sweden with 2 plants, and they will install CC in Slite on Gotland 2030. And they are lobbying for this very hardly, and we believe that we will have it. The market, we are preparing also market for this product, because this is the same material, but with, of course, different level of CO2 emissions. So talking about the product, of course, the installation here, it's very important. But we are still in need of cement. But then we are coming also to the pricing. And if the market is ready to do it, and I would say this is like a combination between the producer, government, or politics, policies, and the clients. We need to know what we are going to have, and if we are ready to accept it. Because all those techniques are actually, yeah, they are costly. But we have no way back. This is also something that we cannot go back. And I'm normally always giving the example. Do we wanna, I'm sorry for taking this example, but we can drive Trabant. But I don't think we wanna go back to this type of cars. They are also taking us forward. But we wanna have a better car, of course.
Yes. It's a good question. Is market ready, or will be ready?
Yeah, I think the Swedish market is the most ready market, and we really see that our customers in Sweden, and Sweden is, by the way, the biggest export market for us, they really demand this product. I agree they are not completely ready to pay really so much more for that, but that really has to develop, also through public procurement, for example, that public procurement really demands the use of CO2 reduced products. But Sweden is really a very important market for that.
I can say that public procurement, actually the use of concrete is actually accounting for more like 40-45%, This means that the power actually in the public procurement is huge. So we expect that this part will be actually covering the need and will push the rest of the industry. And of course, we see the interest from big companies, and those are always having a larger muscles, so they can push the smaller ones and help them also to understand that this is the way actually to go.
Maybe one short comment about Heidelberg Cement. Because you said, and I think that's important, and I did not mention it at the beginning, but we see as well already now there will be a competition for this decarbonized cements, and if there will be decarbonized cement in Sweden from the main producer, then it's for us as exporter very difficult to compete. And if we lose the Swedish market, then we lose the whole efficiency of this plant. So for us, it's also economic importance that we decarbonize. Otherwise, we will lose markets. Same like Norway, for example. We could, if we have a CO2 neutral cement, we can supply Norway much easier than we can now. So for us, it's really, we can create additional markets or first keep the markets we have.
How do you see this? Will it be a smooth transition from a regular cement to a green cement, or this will happen with a stronger regulation policies, procurements, as you mentioned? What's the balance? What will be the balance?
I think it has to be a transition, but yeah, maybe public procurement. I think it has to be a lot of R&D be done, what RISE is doing, but it has to be a slow transition. But the end, of course, we will have a big bang in 2031. At the moment, we think December, we will produce only a CO2-free cement. So, but we have to prepare the market already now in the next 5 years.
And I would say the prices anyway, it will be changed after when the free allowances for emitting CO2 are actually disappearing in some years. So it's either we install the CCS or run the CCS, or we have another type of problem that is also forcing us to pay, or cement industry to pay actually for CO2 emitting. So yeah.
No, at the moment we calculate, depend on the CO2 price, but when we don't have free allowances in 2034, we pay around 100 to 200 million euros per year only for CO2 in this plant, only in this plant. So that's a huge issue, and that's why again for us it's a matter of survival of the cement industry here in Latvia or in general that we do that.
You already mentioned a little bit about how safe it is to store CO2, and I'm wondering if it's that safe. There has been, of course, we read this in the international business press that there have been some backlashes and people are raising concerns and so on. So is this because of a lack of information? It is because it's unknown? Yeah, maybe Kato, if you can share.
Yeah, I would like to say it is a little bit because of lack of information, or this is going a little bit back to Norway. If you look at then when the CO2 tax was imposed to the offshore business in Norway, right? And then Equinor, Statoil at the time, made the decision, okay, we have the CO2 tax to pay, or we do a capture and we store it. And they did that. This is back in 1995, right? So and then they have been storing in this reservoir for now, 30 years. And we have had similar projects in Canada for Quest, for example, over 10 years now, and all around. But of course, it has to be done properly. It's not just about drilling a hole in the ground. It's doing the job, making sure your cap rock is intact, and then even as was mentioned there, even if there is a leak, it's not a bubble that bursts. It doesn't necessarily even go up to the ground because 3,000 meters, several layers of cap rocks and these kind of things makes it, if you do look at the estimations of we're talking about, for 1,000 years, there could be a chance of only 99% of the CO2 staying in the ground. Then you are pretty safe. So it's safe to do, and as was mentioned, if it stays for 1,000 years, most likely, if you try to drill a hole down there, you will find limestone, right? So, yeah.
What has been the public discussion in Sweden?
Actually, not so much about there are not so much worrying about the actually storing. So it's, I would say, maybe the Swedish audience is a little bit more informed. And as you are asking actually, or implying that the information, the communication needs to be adjusted to the audience. So we need to really talk about this, because there is like a confusion between storing the CO2 under the sea, in the seabed, and with nuclear power waste. And I think people are sometimes mixing those different subjects. So we need to be clear about this, that this is, as I said, CO2 is not toxic. And even if it's going up to the surface, nothing will happen, then we have it CO2 back in the air, but nothing more.
What I'm wondering, and this is a journalist coming out of me here, if you are a leader in some area, it is quite sure that there will be some mistakes then and there. So aren't you a little bit afraid of being leader in this sense, because there are no
of course, as a leader you always have to be brave as well. So but you also have to know the risk, and that's why we are doing as well this pilot plant, that we're really testing this technology, that we are really test different scenarios, that we test different flue gases. The main thing is really about the de-risking, and that's what you always do as an entrepreneur or as a leader, that you, at one point of time, you need to make bold decisions, but of course you need to try as much as possible de-risk them, and that's the way what we are doing. That's at the end what politics have to do as well. Of course, they need to see always the risk and try to de-risk decisions, but at the end they have to do a bold decision and move forward, and I think that's, sometimes certain risk you have to take, but I think for us as a family-owned company, it's a bit easier even, because we have a very strong commitment of our owners, and there is nobody like shareholder organizations or whoever who says, well, why have you done that or that? They support this decision, and they support that we move forward, and they will not blame me or my team when there is something not going perfectly, because they know this is a risk, but they know as well we have to go to the next generation in their family, but as well regarding the climate, and then we still want to have a world where we can live in. So for that we need bold decisions.
Yes. Do you expect also that followers will have much easier to implement this value chain, because we are talking here 2028, 2030, yes?
Yeah, I think we still will be the first or among the first, so they might have it easier on the one hand. On the other hand, it will be, if everybody starts then at the same time, then it will be even difficult to find capacities. I mean, you need construction companies, you need cranes, you need specialists, and we believe that if you are losing this rat race when everybody has started, I think then it's too late, because then there will be a huge run of capacity and it will get more expensive. So I think we want to be among the first.
Just one comment to that as well. I think, and that is also why, we have the things like EU Innovation Fund and so on, that, that will be for the front runners. It will not necessarily be for every other project coming much later, right? If there's not something new. So the first ones who are, stepping up, taking some risk, they will also have a chance to get some of that risk reduced through the likes of Innovation Fund, or in the case of Norway, it was through the state budget, but it's similar thing. You get, because if that is not in place, then of course it will always be best to just be a fast follower and never be a pioneer. And
that's a good idea, the state budget. Because in Norway, actually 90% of investment costs have been funded by the state in this Breivik cement plant. So, that's something, of course, we want to discuss as well.
Yeah, it's always nice to be the first, because then you can put the agenda for the rest and be just, talked about. But anyway, it's, I would say, those front runners or those who are technically advanced and there to put both investment and resources, they are actually winning the market, because the clients will also look at them and not those who are in the back. So it's you are creating a new market. But as I said before, it's not only about the taking care of CO2. It's you need to also communicate what value you are giving to your clients. So it's not only the product by itself, but it's just the value.
All right, we are slowly rounding up the discussion. So just in case, do you have any questions to our guests here? I can provide you with a microphone and you can ask a question. Maybe think about it. I heard you said $500 million in investment. Can you maybe divide it and like say where it will go? I mean, how this will split?
Yeah, actually, it will go behind this kiln.
I mean, in the economy.
There are actually three main parts of this project, and to some extent you can see it in the pilot plant as well. There will be a complete new flue gas treatment, because we take the flue gas from another place with a higher CO2 concentration. We also want to again lower our emission limits, or really comply to lower emission limits, and we know that we maybe need a certain specification for the flue gas. So that's 1/3. Then a bit more than 1/3 is the actual capturing plant, these two big columns with a lot of equipment around. And then the third one is this carbon processing unit. This means liquefaction and purification of CO2 and storing of CO2, because we need to store at least around 8,000 tons, the production of 2-3 days, because maybe there's something with the pipeline or with the train or whatever we use. So that will be quite big, massive tanks. And then, of course, there will be another big investment in the storage and supply chain.
Yeah. With this question, I more thought about how much will probably be absorbed here in the local communities and somewhere nearby with the local workforce, and maybe some materials that you're buying in the local.
Oh, we have, of course. I mean, there are some specialists. So this capturing technology, there is only a few companies in the world who can do it. But of course, for the construction part, like we do now with these two big projects we have at the moment, we use a local company. That's clear. But a part of the equipment will come from, we have now companies here from Austria, Norway, from other countries. But I think we can educate them as well, people here, and we also want to cooperate with universities here in Latvia, that we really develop knowledge here. We are in discussion with our RTU and also Latvia's university to really see how we can utilize this knowledge and create new markets or here or somewhere else. And of course, we will need additional employees. This will run not on itself. We need specialists, chemistry partly, but as well engineering.
So, do you came up with some question? Do you have it? No? I don't see hands. All right. So, is there something I didn't ask, but you most certainly want to elaborate on something?
I can say one thing at least. I think what you're doing with the test facility here is really the right thing. If you look at the experience gained from these pioneers that mainly built these big capture plants in power industry, on coal power a lot. One of the things they all say, they had issues when starting up and so on. They were pioneers and no one had done it before. And they all say this, they spent too little time on actually knowing their own flue gas, knowing how the technology work with their own flue gas, how to do pre-treatment, how to do these things, was spent too little time on. and they get penalized from that later. The good thing is most of them manage to overcome their challenges, and then they are in operation. But you save yourself a lot if you do these things up front.
Yes. Katarina?
It's you are talking something which is important. Is I would say it's we cannot stop to do research and be sure and evaluate it. So it's we need to continue with different aspects of the CO2 question. But what I want to say to you, audience, it's actually just imagine we are small countries. Sweden is also a small country. It's a long, but it's actually quite small, and we are pioneers for Europe. So we should be proud. And I think in Sweden, this is also one aspect that we want to be front runners, and we want to show this to others that it's possible. So if a small country can do it, then the larger should follow us. So just be proud.
Yes. Let's say a big thank you with a big round of applause for our guests.